I would almost say, and now for something completely different. So we're talking about the human factor in human-robot collaboration. And why is this important? Well, I think that it's, wrong one. I think we shouldn't forget the H in HRC. And why is this important? Well, I don't want to dismiss any technical challenges because they are enormous, but because they are enormous, the human in the technological development can easily be forgotten. So this project is about safe technology, and this is extremely important. I cannot stress how important that is. However, when we think about safe technology, we should also think not only about impact avoidance, but have a wider human perspective. So it's also about trust and safe feelings. But not only that, the technology should be workable. So you should be able to read the robot as a human. So it should react predictable. You should be able to communicate with the robot, as Mattia just explained about about this interface. Because the human should stay in control. You shouldn't become the slave of the robot. And it should improve work, for instance, reduce physical loads. So in general, the human layer is also there, or what we did is also there because any change is an opportunity to grow, and also in the field of job quality. And this is also a European requirement, which you will see in proposals. Robotics and AI developments should not only benefit productivity, but also job quality. And this has been our role in the project. So if you talk about human factors, what did we do? Well, first of all, we created a design tool to help structure the design process when you are introducing a collaborative robot. A task planner has been developed together with Unimore. Human-robot communication. How do you communicate with the robot? There are several design issues where we helped out, and in the end, this is something we're still going to do: evaluate the effects on job quality, or at least parts of job quality, because a robot cannot affect every aspect of job quality. This is the design tool where you have several panels. There's a task panel. What are the robot and the human going to do? We have several steps in it. There's an information panel and a parameter panel. And these are the steps. So everything starts with a proper description of processes and tasks. You define task allocation scenarios, who's going to do what, select job quality evaluation parameters, and score the job quality evaluations parameters, and the system also visualizes the results. There's an important point about this, that's to stimulate discussion about the changes you are going to do. This is something that's in ergonomics is extremely important. User participation, discuss about the changes you are going to do. Now, this is, for instance, the analysis of tasks and how you build scenarios. So you list the task, you list task durations in the system, and you assess these subtasks on physical loads, on cognitive loads, psychosocial aspects, and environmental aspects. So you do this before, not after. And then the tool is able to visualize the sequencing of robot tasks and human tasks. Here you see two examples, and if you show them after each other, then you will see that in the second scenario, there's a lot of waiting time, either for the robot and the human. Well, the robot is very patient. He won't mind any waiting time, but the human hates waiting time. Some waiting time is very functional, as in a micro pause, which to recover. But in general, if you introduce waiting time for the human, you will create behavior you may not want from the human. So it's important to avoid this waiting time. And then in the end, the tool allows you to visualize the job quality in certain graphs. I won't go into detail. Then there's the process management tool, which Christian from Unimore explained, and it monitors the human and the robot tasks and it allows flexible task assignment. And this is exactly what you want in a collaborative setting. So it adapts tasks depending on monitoring results, and it limits sets. For instance, it limits heavy lifting, it reduces waiting time, it allows recovery, it reduces exposures to risk, just like you have set in the system to. Very important, give the operator control, because this is one of the most important aspects in job quality. An operator needs to have a certain control, and this is, for instance, in the EMA use case where we have you have flexible task assignment. The operator may receive a task from the system but not be ready to perform this task, and then the operator can tell the system, I'm not ready for this task, I decline the task, or I have done the task, I'm going to do the next task. So there's an ability to communicate with the system and to tell and to ask the robot to do certain tasks. Very important. In general, when we talk about this, this is generally how I experience as an ergonomist. When it's about technical systems, then you see a system optimization focused on the technical part, but the operator is also part of this system. So this system should also be optimized. This is what we did in the Rossini project, and we stress that you should also look even larger, to look at the big picture, because this is the full system that you want to that needs to operate in a perfect manner. And this is exactly what we call ergonomics, which leads to sustainable productivity, and this is exactly what you want. And with that, I thank you, and we can go on to the next speaker, and questions can come afterwards. Thanks.